Odoo 16. So it's a rather technical talk, so if you are not technical, you can jump to my neighbors and hear what they have to say. If you have questions, you can go to this URL, odoo.com/r/askfp. I will answer your question at the end. All right. So the human eye can see 35 frames per second. It's 30 milliseconds per frame. So it's very important when we draw a screen in the browser to be within these 30 milliseconds. A blink is 150 milliseconds. So in order to get to that level of efficiency, we need to improve every layer of the stack. So it starts with the hosting and the hardware. It has to be super fast. Then we have the Odoo server framework, Python. Then we have the business feature. And then everything is transmitted to the web client, and the browser has to be very fast. So the goal for Odoo 16 was to have all these stacks perform in less than 150 milliseconds. So the performance that we measure is always the sum of all these layers. In the past, we used to improve locally some of the features, but now we wanted to have the full stack that is very fast. So let's have a look at what we did, and starting with the web client. First, we redesigned our new library, JavaScript, that renders virtual DOM. It's actually called block DOM. We released a new version of our framework, OL2, which is very fast. We did a CSS cleanup. We decreased the number of CSS rules so that the browser can render much faster by 50%. We reduced JavaScript dependencies, and we moved from Bootstrap 4.3 to 5. Let's drill down. That is a website that compares all the framework that exist in JavaScript. The one we use, which is block down, is here, the second column. It performs 7% slower than the vanilla JavaScript, so the perfect code that renders the different scenarios that we have here, create a row, select a row, and so on, read memory. It's only 7% faster that everything is implemented perfectly in JavaScript. To give you an idea, modern framework like React is 2.53. Or Angular is 2.59. So we are an order of magnitude much faster than any other framework on the planet, JavaScript framework on the planet for the virtual DOM. That is block down. That was the first component of the new version of OL2. So as you can see here, we are there, and the traditional framework, even Svelte, which is a good and new framework, performed 28% slower than what we did with block down. So thanks to Jerry, we did an amazing job there. We have a very, very, very fast virtual DOM library. And then on top of that, we built the new version of OL, which is OL2. In the past, in Odoo 15, we had 70% of the code which were implemented on legacy widgets, and 30% was on OL1. Now, in Odoo 16, 99% of the JavaScript code is ported to OL2. We have a few exceptions, but it's in very specific areas, like in Studio, where we still have to port the JavaScript code to OL2. The impact is 30% reduction in the number of lines of code. So not only it's much faster, but it's also lighter. And the speed, depending on the screen, goes from 2 times to 20 times faster, depending on the view. Pivot view gets 20 times faster to render, and other views are 2 times faster. And historically, when we moved from widget to OL1, we went to a virtual DOM, so it improves everything. So we could apply all the changes to the DOM in one step, and we avoided all these query selector and change the DOM at different positions at different times. Now, when we move from OL1 to OL2, the new version of our JavaScript framework, we have a much faster virtual DOM because of block DOM. One of the reasons is that we don't do diff of DOM. Most of the virtual DOM libraries, they have different diff of different DOM, but a DOM can be very complex. You have a lot of different nodes. We diff the values, and based on the values that change, we know which node of the DOM have changed. It's much faster than comparing 2 different DOMs and applying the changes. We also are able to render a parent without the children. That's very efficient, especially in complex applications like in Odoo. We don't compute invisible zone. So if you have a notebook with multiple tabs in Odoo, the JavaScript is smart enough to only compute the zone that is visible on the screen. And we also regroup HTTP queries. So if you have multiple tags on different cell order lines, there will be only one HTTP query. And those elements, amongst others, makes the new JavaScript framework much faster. We worked on the CSS cleanup. We have a team, or mobile team and designers that did a massive amount of reduction in the number of CSS rules. And that impacts the capability of the browser to render your screen fast. So to do that, we upgraded Bootstrap from 4 to 5.1 for both the backend and the front end. And we cleaned up all our internal CSS rules. And as you can see, there is a massive difference depending if it's on different business application, mail, views, or web the client. But all in all, we shrink the number of CSS rules in Odoo by 68%. So that means that the rendering of the browser is faster. That's not all. We also did different improvements in the web client. One of the funny ones was the search bar counter. You know, when you have the counter of the number of records, if you had millions of records, the database had to process every sequence scan on all the records on your database just to know that you have 9,700,000 records. In the new version of Odoo, what we do, we count up to 10,000, and if you have more than 10,000 records, then you get 10,000 plus, but then instead of taking 4 seconds to compute, it's 20 milliseconds. If you want, you can still click on the 10,000 plus and you get the real number. So you still have access to the information, but only if you need it, because most of the time, you don't care that there is 9,000 something CRM opportunities or contacts. What you care is that it takes 20 milliseconds rather than 4 seconds. We reduce the number of RPC calls a lot, especially the tags in the one-to-many, when you have sale order lines and different taxes on the sale order line. Now it's only one HTTP query rather than one per line. So that improved a lot the capabilities to get the data from the server. Also, the progress bar that you have on top of an opportunity, there is no more HTTP request. We receive the data from the initial read, so less queries means faster. We did a complete refactoring of the chatter to improve the performance, and more specifically, we went from long polling to WebSocket, which is also faster. All right, I can show you a live demo after. We worked on the network. In order to be fast, you need your web client to be fast, but you also need the transfer of the data to your web client to be very fast. So in order to do so, one of the things we did is to reduce the number of HTTP calls for a query. We went from some screen, like opening an invoice, from something around 12 HTTP calls to 4 now. And amongst these 4, 2 are lazy, so you get only 2 and then 2 after. We reduce the file size of pretty much everything, like when you call fields view get, when you get the views and the fields. Now it's much lower. And we also reduce the workers' dependencies on Odoo. I will explain you how. To reduce the HTTP call, on the front end, we merged the command, and we had 2 assets, what we call command and front end. So it was 2 JavaScript files and 2 CSS files. Now we merged them, so we have only 1 CSS and 1 JavaScript to load any page. So less back and forth with the browser and the server. We remove unused queries that we had. We had a few. And so now when you go to load the /web controller, we went from 15 HTTP queries to 9. It's a 60% reduction of the HTTP queries to open the backend. We reduce the size of the views, you know, the sale order invoice views. That's what we call load views, the controller in Odoo that gets this data. And we did that by, there was some redundancy between the fields. The fields were described in every views you were loading. So if you were loading a graph view, a Kanban view, a list view, and a form view, you had multiple versions of these fields, the same fields. By removing that, we only have 1 field per call, not per view. And so we reduce a lot the volume of data transmitted. And we also avoid redundancies in the views. For those you know, we have ATTRS, which was also described as invisible or read only equal true. And we remove these redundancies. So the data has been reduced by 35%. And one of the things we did also to reduce the load on your workers is to delegate the delivery of large files to Nginx. So now Odoo, the server comes with a new argument, which is --x send file. When you say that, the assets or the large file can be delivered directly by Nginx rather than by Odoo workers. So we reduce the load on your Odoo workers and the number of HTTP concurrent requests you can handle, and Nginx will do it for you. So before, when you add a request, the browser had to download everything from Nginx, and Nginx had to request everything from the Odoo worker, all your assets, CSS, JavaScript, and everything. Now, most of the assets, they are transmitted to Nginx we don't send the asset, we just send an HTTP XAXL redirect metadata to Nginx, and the Nginx can send the documents to the browser himself. So that reduces and frees the worker, Odoo worker directly, so that one single worker can handle way more transactions than usual. That was for the business apps. We improve a lot the business app. One of the biggest changes we did is just to move from the on-change legacy method to the compute one. That's been a lot of refactoring, and I'll explain you why it's great. Why compute are better than on-change. Let's say you have a sale order like this. With on-change, every time you change something, like a discount, you had to modify the subtotal, and then you had to modify the untaxed amount. And the thing is, he had to do it for every line. So if you were changing the discount of the 3 lines, you were calling the computation of the subtotal and then the computation of the total here for every line 3 times. With compute, they have a mechanism where you can compute, when you can flag everything that has changed, and then you only compute them at the end. So you compute only once the total and the taxes. Sorry. So compute are much better. From the client side, it's the same. So even though on the server side we implement the feature with compute, on the client side, it's still on-change method that the client sees. So the interface is the same, but behind the scene on the server, it's much easier to implement. There are lots of advantages of using compute versus on-change. Some of them is that it's cleaner. It separates large functions into smaller ones. Like on-change partner ID on a sale order is very complex because it changes a lot of things, like your address, your price list, the lines of your product. So nobody knows what on-change on the partner ID can do. But if you revert that and say, okay, how is the address computed on the sale order? You know that it comes from the partner. How is the price list computed from a sale order? You know that it comes from the partner. So by reverting and implementing these with compute fields instead of on-change method, everything gets easier in the code. So here is how it looks like. On-change is now implemented by computed field, which are translated to on-change calls for the web client. But you see the code is shorter. And you have less operation. We also introduced on the fields pre-compute equal true. When you do pre-compute equal true, instead of inserting the data, computing the computed field, and then updating the database, it computes the computed field before inserting them in the database. That means that you have only one insert and no update. All right, we also improved the Python server, most specifically the translated fields. In the past, in Odoo, you had the data like a country in a separate table, and then you had a table higher the translation with all the translation of all the terms from every database. And this created congestion, because every request you had on different tables needed to create a join with this very large database of all the translation from Odoo to just return the to and Belgique, the name that is translated. In Odoo 16, now instead of storing the translation in a separate table, we store the translation on the record itself as a JSON data. So on the country, the ID2, you have both the English and the French version on the record. That means that when we have to retrieve the French version of a record, you have everything in the same page in PostgreSQL. So it's very fast. You get the to and Belgique right away without having to create joins. And that's way, way faster. It's on average 1.5 faster for every read. I mean, every read in the system, because every read when you work in multiple languages, it's a lot. But for the XML read, like you read the views or description of a product, that's 7.4 times faster. Because before that, we had to isolate all the terms of the XML, join them with the higher translation table, and recreate an XML that is translated for the language. That was very compute intensive. Now it's 7 times faster because you have all the translated value directly on the record. Search are faster too, especially with ILAC, and we require less flushing on SQL Server. The only drawback is installing a new language is 2 times slower, but it's only at the installation of the database because you have to update a lot of records rather than just the IR.translation table. We introduced for the front end fragment caching. So it's a method to cache the data in Odoo, but caching is very complex because some elements of your page, like the signing, is dynamic. I mean, some users are signed in, so others are not. Maybe the price is dynamic too, because you have different prices on your website. So here you have the HTML of the page. What you can do now with Odoo 16 is introduce tcache on some areas, like this area and this one. and it will tell you which areas of the system you want to cache. And so we'll create a cache instead of computing all these areas directly. And you can create different cache, and some cache might have some keys. Like this cache depends on the products and the price list, this one. So you may have different version of this cache depending on the products and the user is viewing and the price list. And so we don't need to compute anything just to render this page because we have the different cache layers, fragment cache, and some are depending on different attributes, so it's easy. And this one, for instance, the green one, depends on the fact that the user is logged in or not. On average, we went from 100 milliseconds to open your shop to 25 milliseconds while respecting all the conditions. Multiple users have multiple price, multiple products. So it's a huge speed up on all the page thanks to the fragment cache that we introduced for the front end. We also improved the indexes. In Odoo 15, we only supported index equal true. In Odoo 16, we now have different types of index. B3, B3 not null, where we don't index the null values. Trigram, which is much better for looking inside strings, because B3 cannot be used when you have a I-like operator. And of course, you can also create index manually for very complex index, but that does a lot of job. And changing these index improves a lot, also most of the operations. Views and menu, we created a cache on the views and the menu. That means that now loading the views in the backend and the menus is 6.5 times faster, very, very fast. Session, before every time you had a visitor on your website, we created a session on your file system. The impact on our own database, Odoo.com, we had 30 million of sessions. That was 117 gigabytes of data. Now we only create a session when we need it. Like if a user puts something in his cart. If it's just a visitor that view page, we don't need to store something. Like he doesn't put anything in his cart, we don't store the session. And we went from 30 million session to 200K session, 0.8 gigabyte. And of course, that translates into faster website too. And last but not least, if we want everything to be fast, we need to work on every layer. So we also worked on the hardware and the hosting. So on Odoo Online, we upgraded most of our servers. We went from HTTP 1 to HTTP 2. And now, as a summary, on my old laptop, on this new one, it's 2 times faster, but on my own laptop, I went from 552 milliseconds to open this document to 150 milliseconds to open the invoice, 3.5 faster. Less SQL queries, that's the number of SQL queries to visit a web page. And also 3.9 times faster on the front end. Let's have a look. I have here the different websites, one in version on the port 16, I have the version 16, and on the port 8070, I have the port. You get it. And let's use AB, and I will ask. I will do a query. So it's Apache benchmark. /shop, and we'll see I will run 100 queries in parallel, and we'll see how much time it takes. And that's on the version 15. So it's running 100 queries. It's taking 74 milliseconds per query. If I do the same on Odoo 16, instead of 74 milliseconds per request, I am now at 29 milliseconds per request. It's really much faster. All right, I'm going to check if I have time for the questions. Do you have benchmark? Yes. 10 minutes for questions? Okay, good. Yeah, I showed you some benchmark already. The ones I showed you for BlockDOM was someone that was made by a third party, so not by us, who analyzed all the JavaScript libraries that exist. Since a visitor of a website does not start a session, is it a website visitor? Yes, it's still tracked in the statistics, so it's a website visitor. It's just that we don't store a file on your file system for the session, but in memory, we still have a session for this visitor. When you measure performance and announce 150 milliseconds, what are the network latencies? Everything I announced was computed locally to avoid the network effect, but you can still test on runbots going from one or online from one record to another. It's still very fast because that reflects. So let's go to our runbots, which is our development environment. I'll open this one, and you'll see that even there, it's very, very fast. So let's go to, I don't know, CRM, opportunities. You see, you don't see the screen moving. And if I go to next, 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 and it's really, really fast, despite that I am on the web. So the numbers I gave you were on local, but if you do it on the web, it's also extremely fast. How large is the test database? We have tested with different size. We have the one I showed you with the counter was our own database, which is running on millions, 100 millions of account move lines. Yes, you can get demo data to test for large database. There is actually an argument in Odoo, which is populate when you run the server, that creates a lot of data for you to test your performance with demo data, but with large volumes. Does this performance improvement apply with custom code? Most of them, yes. Most of them, like the new translation mechanisms, the cache system, everything is in the framework level, so that helps custom code. We have some improvement that were local, so your custom won't benefit from it, but most of them, your custom code will benefit from these improvements, especially for JavaScript. All the modules we develop use the JavaScript client. Yes, all these improvements have been made in Odoo community, so Odoo community benefits from all these improvements as well. Will the widgets be unsupported by Odoo? Yes, it's still supported in version 16, but we will drop the support for widgets in Odoo 17. Yes, the point of sale has been fully ported to OWL 2. Basically, all the business apps of Odoo have been ported to OWL 2. That was a massive refactoring of everything. No, we don't want to support anything else than PostgreSQL. PostgreSQL is very, very good. We do support, so the attribute I showed you was for engines, but Apache has the same mechanism, which is a X send file, I think. And you can use the same attribute for Apache. So thank you. It's time for me to close. I hope I couldn't answer every question, but I did my best to answer most of them. Thank you.